Remember from section 3.1 we've already discussed that if we're going to be working with sine, that we're only going to work with this side of the unit circle. We're restricting our domain to go from negative pi over 2 to pi over 2. When we talk about cosine, we're just working with the top half of the unit circle, going from 0 to pi. And for tangent, also negative pi over 2 to pi over 2, working with that side of the unit circle. So when we start talking about cosecant of theta and the secant of theta and the cotangent of theta and their inverses, we're again going to restrict the domain. And it's going to be the exact same as what we've already done. We're talking about from negative pi over 2 to pi over 2 for cosecant. We're talking about from 0 to pi for secant. And we're talking about from negative pi over 2 to pi over 2 for cotangent. So here we're showing the domain that we're going to limit the functions to so that our inverses will also be functions. Here we're finding the exact value again, and when we look at a problem like this, we're finding the sine of the inverse tangent of 1/2. So this value here is our angle. That's our theta. And then this whole part here, we're talking about the side of a triangle. That's our length. So when we're looking at this, first thing we need to do is we need to find our angle. So we want to look at, well, we know that the angle is equal to the inverse tangent of 1/2. So we can say that the tangent of theta is equal to 1/2, and that's not on the unit circle. So what we want to do is we want to set up a triangle. So if we draw ourselves a triangle, we know that for tangent, we're talking about opposite over adjacent. So we're going to set up our triangle. Here's theta. And we just said opposite over adjacent, so we have 1 over 2, and now we need to find the hypotenuse. Pythagorean theorem. 1 squared plus 2 squared equals 5 squared, so that side would be square root of 5. Now, we don't really need to find our angle here. What we were really looking for is the sine of this. So all we do now is use our triangle to find the sine of theta. We know that sine of theta is equal to opposite over hypotenuse. So we can now plug in opposite over hypotenuse. So the sine of theta is equal to 1 over the square root of 5. And of course we want to rationalize the denominator, multiply top and bottom by square root of 5 over square root of 5. So we end up with our answer, square root of 5 over 5. That would be that length. We don't actually have to find the angle here. So same idea here, cosine of inverse sine of 1/3. Again, this is our angle. This entire part here, that's a length of one side of the triangle. So we can use this to set up our triangle. We know that sine is opposite over hypotenuse. So we're going to say here's our 1 and here's our 3. We know that we're going to be in quadrant 1 because this is a positive value. Same idea on the last one. I didn't mention that. It's positive. We're in quadrant 1. Remember, we've restricted our domain, so if we're talking sine or tangent, it's going to be quadrant 1 or quadrant 4. If we're talking about cosine, it's quadrant 1 or quadrant 2. So pay attention to quadrants still when we're setting up those triangles. Again, we can use Pythagorean theorem here. 1 squared plus x squared equals 3 squared. So x squared is equal to 9 minus 1 is 8. So x is equal to 2 square root 2. That's our value right here, 2 square root of 2. Again, we don't need the angle. We need to find the cosine. And the cosine of theta is equal to adjacent over hypotenuse. Here's our adjacent, 2 square root 2. Here's our hypotenuse, 3. So our exact value for the cosine of theta is 2 square root 2 over 3. Here's another example. Here we have the tangent of the inverse cosine of negative 1/3. Again, this value is our angle. So we're going to set up our triangle. It's -1/3, so for cosine, that's going to be in quadrant 2. So here is theta. Cosine is adjacent over hypotenuse. We know that our adjacent is going to be our negative value because we're in quadrant 2. Hypotenuse is 3. So again, we can find our third side of our triangle using Pythagorean theorem. So we're going to again find that y is equal to 2 square root 2, and that is going up, so it's a positive value. So now we have our triangle. So now to go to the tangent of theta, we know tangent is opposite over adjacent. So in this case, our opposite value is 2 square root 2. Adjacent value is -1, so that's going to give us a -2 square root 2 for our exact value. And if we're looking for the inverse of the cosecant or the cotangent or secant, remember inverse, we're looking for an angle. So what we can say is this is going to be equal to our angle. And for cosecant, well, we know that that's the same as 1 over sine. So we could also think of this as the sine of theta is equal to, and then take the reciprocal here of 1/2. So that's what we're going to look at there. So where is the sine of theta? So I've taken the reciprocal of this and this value. We could also set up a triangle here. We know cosecant is equal to hypotenuse over opposite. And so if we were to set up our triangle, we're in quadrant 1 because we're talking about cosecant. Here's theta. Opposite is going to be, so we're thinking of this as 2 over 1. Opposite is 1. Hypotenuse is 2. Now just find the sine of that value. Take the reciprocal there. So theta is equal to, where does that happen on the unit circle? Pi over 6, or 30 degrees.